Day 689 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1594, maximum non-negative product in a matrix. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. You are given an n by n matrix grid. Initially, you are located at the top left corner 0, 0, and in each step, you can only move right or down in the matrix. Among all possible paths, starting from the top left corner 0, 0, and ending in the bottom right corner n-1 and n-1, find a path with the maximum non-negative product. The product of a path is the product of all integers in the grid cells visited along the path. Return the maximum non-negative product modulo 10 to the 9th power plus 7. If the maximum product is negative, return -1. Notice the modulo is performed after getting the maximum product. All right, y'all, so that sounds a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input grid equals a 2D array of integers or n by n matrix with the first row being -1, -2, -3. The middle row is -2, -3, -3, and the bottom row is -3, -3, -2. Now, before we keep going, just remember each one of these arrays represents a different row, right? So this is the bottom row, boom, this is the middle row, boom, and this is the top row, boom. Now let's continue. The output is -1. It says it is not possible to get non-negative product in the path from 0, 0 to 2, 2, so we return -1. So in this grid right here, it's impossible to get from this cell to this cell and have a positive product, right? Because remember, a negative times a negative would be a positive, and then a positive times a negative would be a negative, right? So since all of these are negative in this 9 cells, it's impossible for us to get a positive number out of these no matter which path we take, right? So that's why the output is -1, right? We might go -1 times 2, that'd be 2, but then we go -2 times, then we go 2 times 3, that'd be -6. Then we go -6 times -3 might be positive 18, but then once we do the positive 18 times the -2, we back into negatives. And that pattern will continue no matter what path we take, right? So the output is -1. So let's take a look at example 2 where it is positive. So it is possible, sorry. In example 2, our input grid equals a 2D array of integers or an n by n matrix with the first row being 1, -2, 1, the middle row being 1, -2, 1, and the bottom row being 3, -4, 1. The product or the output is 8. Explanation says the maximum non-negative product is shown. 1 times 1 times -2 times -4 times 1 equals 8. So we take this path right here. When we multiply every integer in this path, it'll come out to be a positive number. It'll come out to be 8, right? And that's the maximum that we can obtain. So that's why we return 8. We might be able to get positive numbers from different paths, but it wouldn't be the maximum positive number. We want the maximum positive number, and in this case it's 8, so that's why the output is 8. Now let's take a look at example 3. So in example 3, our input grid equals a 2D array of integers or n by n matrix with the first row being 1, 3, bottom row being 0, and -4. This time the output is 0. It says the maximum non-negative product is shown. 1 times 0 times -4 equals 0. So this may seem a little like a little trick question or something, but 0 counts as a positive number. So in this case, we could just return 0. Boom. So now that we understand the question, y'all, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we need to do is we need to get the number of rows. So we're going to say let m equal grid dot count. Boom, that'll get the number of rows. Then we're going to say let n equal grid square bracket 0, come outside of that, dot count. And sorry, this right here is going to get the number of columns. This is going to get rows. This is going to get columns. Boom. Now we're going to create another variable to store the minimum product to reach a cell, or to reach a cell, and we're going to start with the first cell. So sorry, we're going to store the minimum product to reach cell current row, comma J. I'll show you what that looks like as we continue, but for now we could just declare a variable called min vals colon. It's going to be an array of integers. Come outside of that and we'll say, sorry y'all, that's going to be an array of integers. Come outside of that, we're going to say equals. It's going to be grid, open up the square bracket. It's going to be grid, so square bracket 0, and still inside the other square bracket, another square bracket 0. Boom, just to start as a default value. Now we're going to initialize the first row. Since we can move only right, we keep multiplying along the row. So we're going to say for j in 1 ... less than n. We'll open up the brackets and we'll say min vals dot append. Open up the parentheses. We'll say min vals, sorry y'all, it should be vals square bracket j minus 1. Come outside of that and we'll say times grid square bracket 0 square bracket j. Boom. Now we're going to create another variable to store the maximum product, and initially it's going to be the same as min vals for the first row. So we'll come underneath this for loop, declare another variable. We'll call it max vals, say colon, going to be an array of integers. Come outside of that, set it equal to min vals. Boom. Now we're going to iterate through each row starting from the second row. So we're going to come underneath this and we'll say for I in 1 ... less than m. We'll open up the brackets. Then we're going to iterate through each column. So we'll say for j in 0 ... less than n. We'll open up the brackets. Boom, and we'll say let val equal grid square bracket I square bracket j. Boom. Then we're going to compute products coming from the cell above or the same column. So we'll come underneath this and we are going to say let min up equal min vals square bracket j. Come outside of that times val. Sorry y'all. Boom. Then we'll come underneath this and we'll say let max up equal max vals square bracket j times val. Boom. Now we're going to initialize the current cell values using the from top transition. And it's important to know that negative values can flip from the min to the max. So we'll come underneath this and we'll say min vals square bracket j, sorry y'all, min vals square bracket j equals min, open up the parentheses, min up, comma, max up. Boom. Then we'll come underneath this and we'll say max vals square bracket j equals max, open up the parentheses, min up, comma, max up. Boom. Then if we can also come to the left cell, we'll come underneath this and we'll say if j is less than 0, we'll open up the brackets and we're going to consider transitions from the left. We take both min and max because multiplying by a negative can turn a small value into a large one and vice versa. So we are going to say min vals square bracket j. We are going to set that equal to, we're going to set that equal to min, open up the parentheses, and I'm going to just indent this just to keep it clean. We're going to say min vals square bracket j, come outside of that, comma. Then we can come underneath that, we'll say min vals square bracket j minus 1 times val, comma. We could come underneath that, and then we could say max vals square bracket j minus 1 times val. Boom. Then we'll come underneath this and we'll do the same thing for max vals. So we'll say max vals square bracket j equals, equals max, open up the parentheses, boom, we're going to say max vals square bracket j, come outside of that, we're going to say comma, then we're going to say max vals square bracket j minus 1 times val, comma, come underneath that and we'll say min vals square bracket j minus 1, come outside of that, times val. Boom. Now our final result is going to be the maximum product at the bottom right cell. If it's -1, we can if it's negative, we can return -1. Otherwise, we need to return modulo 10 to the 9th power plus 7. So we come down here and we can say return max vals square bracket n minus 1, come outside of that is greater than or equal to 0, question mark, max vals square bracket n minus, n minus 1, come outside of that, mod 1 underscore 000 underscore 000 underscore 007. Boom. Else, or come outside this, we'll say colon 1. So, boom. If this right here is going to return a Boolean, true or false. So if this right here is true, then it'll return this. If it's not, this should be a -1. If it's not true, then we'll return -1, y'all. So that should be all she wrote. Let's give it a run. Make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all. Matter of fact, before we go, though, make sure you get one more look at the code. This is the top part, and this is the middle, and this is the bottom. And with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.